Hi folks, today we're going to concentrate on finding the rational zeros. Now the rational zeros, those are the places where the graph of your polynomial is going to cross the x-axis. Now the best way to find possible rational zeros is just laid out right here, p divided by q, where p is just the factors of your constant and q is the factors of the leading coefficient. All right, it's always very nice to have your leading coefficient be 1 because then you have much less work to do. But the bottom line is we need to kind of know and kind of have an idea of what our possible factors could be, because this is going to be very hard to factor if we don't have an idea of where to start. So now we're just going to take a look at this 12 right here. That is basically p. It's the factors of the constant term. And over here, since our leading coefficient is a 1, there's really not much to do. So we take a look at the factors of 12, which would be 1 and 12, 2 and 6, 3 and 4. So the factors, the possible factors, would be plus or minus 1, 2, 3, 4, 6, and 12. Those are the possible factors. Those are the possible zeros that we could take out of this equation. And that's done. Okay, so now we're going to turn our attention to the next one right here, where we take a look at the factors of 6 divided by the factors of 2. So the factors of 6 are 1 and 6, 2 and 3. And then the factors of 2 would be 1 and 2. So the possible factors that we can get out of that would be plus or minus 1 over 1, 2 over 1, 3 over 1, and 6 over 1, or 6. And then we now have that 1 as a denominator, so we can go ahead and get rid of that. Now we're going to focus on the 2 as a denominator. So we also have plus or minus 1 over 2, 2 over 2, 3 over 2, and 6 over 2. But one thing I want you to notice is a couple of these have been listed twice. The 2 over 2 is the same as a 1, so we don't really need to worry about that one. The 6 over 2 is the same as 3, so we don't need to worry about that one. So our possible factors for this then would be plus or minus 1, 2, 3, 6, 1/2, and 3/2. Those are the possible factors. So this next one, what I'd like you to do is have you try and figure that one out. Try and have you figure out the possible zeros for it. Now we're going to practice actually finding the zeros here, and that's what it says. Find the rational zeros. What are our rational zeros in this? So first off, we can go back to some of the things we've learned, and we can take a look at these sign changes for f of x. We have one sign change happening from plus to minus right here, which means that we're going to end up with one positive solution. All right, and then if we were to find f of negative x, to figure out how many negative zeros we should expect, we would have negative x cubed plus x squared plus 3x minus 6. So here again we can count our sign changes, and we get one sign change here and another here. So we're going to wind up with 2 or 0 negative responses, which means we could also have 2 or 0 imaginary responses. So now we need to figure out what are the possibles that we could come away with. So since our leading coefficient is 1, all we're worried about is the factors of the 6. So our possibles would be plus or minus 1, 2, 3, and 6. So now it's just a matter of finding the right one that's going to go into our little box. Which one is a 0? And I'm going to pick 2. And here we're going to go through our synthetic division to see if it works. So we bring in our coefficients. And if this is an actual solution, we should get 0 right in that box right there. So now, going through the motions, we bring down our first, and we go through the motions, multiply, add. So 2 times 1 is 2, add it down, we get 3. Multiply, 2 times 3 is 6, add it down, we get 3. Multiply, 2 times 3 is 6, add it down, we get 0. So we got what we wanted. This 2 is one of the zeros, so we know that x would equal 2. Here's our remainder, here's our constant, here's our x term, here's our x squared term. So we have x squared plus 3x plus 3. So now we can go ahead and figure this out, figure out what the other zeros are by using factoring or the quadratic formula, which in this case I think would be the best way to go. So we can go ahead and plug in x equals opposite of b, so negative 3, plus or minus the square root of 3 squared minus 4 times 1 times 3 all over 2 times 1. So x would equal negative 3 plus or minus the square root of 9 minus 12 would be negative 3 all over 2. So here we're taking the square root of a negative, so it's going to be an imaginary solution. So x equals negative 3 plus or minus I root 3 over 2. And we know we should be coming out with 3 solutions because this is third power. So here's one of them, and here's the only real solution, and here are 2 imaginary solutions, just like we said was possible. All right, here's one that I want you to kind of try on your own and go through those motions again. See how many positive solutions you should expect, how many negative you should expect, and how many imaginary to expect. And when you go through this, you should get x equals 4, x equals negative 1, and x equals 5, which makes sense since we have 3 solutions. Okay? So now I'd like you to practice this, so go ahead and do page 374, numbers 3 through 35 odd. Best of luck to you. We'll see you in class.